Hi friends, we're going to try to record lesson 3-4 again. We've had the lesson a couple days ago, but I've been struggling with getting the computer to work the way that I need. So please be patient with me as we try this the 4th time. So hopefully it'll all be good. Now we need to review a few things because we're talking about the polygon angle sum theorem, and one of them is a triangle. And a triangle, we'll find out, is the smallest polygon. And the angle sum theorem tells me if I have a triangle here, and I have its 3 angles, I know the sum of those 3 angles, no matter what, and this works for any triangle, will always add up to 180 degrees. So then, as we were working with the exterior angles of a triangle, so the exterior angle theorem, we found out if we have a triangle and we extend one side to form an exterior angle, we'll call that 1. We know the 2 remote interior angles, which I call here 2 and 3, are going to add up to our exterior angles. So we know that the measure of angle 1 is the sum of the 2 remote interior angles. So it worked out pretty easily. But then we have to define what a polygon is. And a polygon is a pretty simple thing. A polygon is a closed plane figure with at least 3 sides that are segments. So the sides intersect only at their endpoints, and no adjacent sides are collinear. So we need to make sure that we can fulfill that definition. So we look here, and we have to decide if the following 3 figures are polygons or not. Well, the first one is a polygon, and many of you would probably recognize it. You'd say, oh yeah, that's just real simple. And that's going to be a pentagon. So that is a polygon. Why? Because it's a closed figure. And we know the next one's not a polygon because it's open. We need another line segment right there. So we'd say not a polygon. It's an open figure. And then the next one is also not a polygon. Now basically it's really a figure made up of 2 polygons. And I just spelled polygon wrong. How embarrassing. Anyway. It's not a polygon because it says that no sides, basically every line segment has only one, 2 line segment, endpoint has 2 line segments coming from it, and it doesn't have any overlap. So this point right here makes it not a polygon. But we have to be able to identify the different parts of a polygon too. So when you name a polygon, you write the fact it's a polygon down because we don't want to confuse it with anything else. And so we say, all right, it's a polygon. And you start at a vertex, let's say like at A, and you go clockwise, or you go counterclockwise all the way around, and you go in what's called consecutive order, one right after each other. So we go A, B, C, D, E, if you go at A, and you go all the way around. Or you could go counterclockwise, starting here, and you'd go A, E, D, C, B. Now, if you don't like any of those, you can pick a different vertex and just, again, go around clockwise or counterclockwise. But be very careful. When we get more specific with our names, we could also be very specific name for our polygon, because that would be a pentagon. Let's say I wanted to start with C, and I could go C, D, A, B. That's going at C and going clockwise. So you can be more specific if you know the more specific name of that polygon, like which we do with triangles. It's the same way. But understand what does not make a polygon when you name it. If I went to like random spots, let's say I went from A to D to C to B down to E, notice I didn't make a polygon when I played connect the points. So this would not be a polygon. So don't do it that way. Now, we're also supposed to call the vertices, and the vertices are the endpoints of the line segments. And it is points, so make sure your rotation is capital letters. And we go A, comma, B, comma, C, comma, D, comma, E. Sides are line segments, so you have to use the correct notation with sides too. So I'm going to start with A, and I'm going to go around this with using the endpoint. So segment AB, segment BC, segment CD, segment DE, segment AE. You better have 5 sides because it's a 5-sided polygon. Also, then we have our angles. We have angle A, angle B, angle C, angle D, and angle E. So we can name all of those. So now let's go and let's finish up right here with identifying this next polygon. We'll just do an example. Now again, I don't know the name of it specifically. I do, but we're going to act like you haven't learned it yet. A polygon, and you just pick a point, and I'm going to go D here, and I'm going to go counterclockwise this time. So I'm going to go D to C to B to A to F to E. Now remember, it doesn't matter which vertex you start with, as long as you go clockwise or counterclockwise. And then we have to name the vertices. They're just our endpoints. So we go points. And we'll just go ahead and name them in order. It's easier to keep track of E and F. Then we have our angles. And every vertex is going to be the vertex of an angle also. So we're going to go angle A, angle B, angle C. Now if you want, let's just say I want to name angle E with 3 points. Just make sure you name the vertex in the middle. And that would also work. So that would be going for our angle E. And let's just say I was doing the same thing for angle F. So I can go angle F is going to be E, F, A. Just remember correct notation. You can use 3 points also. It's very important. And then we have our sides. And those are your line segments. So segment AB, segment BC, segment CD, segment DE, segment EF, and segment AF. For our 6 segments. Now, it's not that hard for us to figure out, but hopefully we'll go and we have to now classify our polygons by either convex or concave and also by the number of sides.